Okay, hi everyone. My name is Filip Křepinský. I work at Red Hat, and this is Ryan Hallisey, who works at NVIDIA. And we would like to introduce you our new working group called Node Lifecycle. So we are both interested in the pod and Node Lifecycle, as these are very much connected. And we basically look at various issues and use cases, like spanning from pod deployment to like a cluster on Node Lifecycle. And we would like to improve like current situation of pod and Node Lifecycle and come up with new solutions. So this is like a cross-SIG effort, which lies on the crossroads of many SIGs. So we are so we would welcome everyone's feedback and collaboration when working on these issues. So let's start first talking about the pod. I know this is like everyone knows what the pod is, but let's talk about the implications. So one of the big or important topics when talking about the Node Lifecycle or pod lifecycle is observability. And there are multiple ways how you can achieve observability of a pod. One of the most like a common or simple ones is like pod phases, which, as we know, is not a great representation of a pod lifecycle. We have some other ways how to represent like the state of the pod through the pod status or some other means. But I mean, it's like this. Like when we talk about observability, it's not that we want to have just like a nice set of points to plot a nice graph. Observability is useful like for cooperation between multiple components, and it basically helps us solve many various problems. So like this is, for example, the higher level workloads. So for example, when you talk about the job API, it interacts with and observes the pod states. And I think like there is something missing here. So we I try to like come up with like a much more complicated state machine, which is just for illustration how I will zoom in a bit. Just to showcase like what kind of issues we run into when talking about the pod lifecycle. And I'm not diving into the container lifecycle here, since we look at it more from like the application perspective, that you want to run some process, and you want to see how it starts and ends, for example. So like when you create a pod, like the first thing that has to happen is scheduling. So once the pod gets scheduled, it doesn't mean like there are issues there already. So kube scheduler doesn't have all the relevant information it needs to like fully, or like I mean to schedule the pod well. So kubelet or container runtime can actually decide that there is not enough resources, or for example, you get like denied sysctls, or like maybe the node is already draining or like shutting down, and so even the pod got scheduled to this node, it might not be able to run. And what kubelet does, that it fails the pod, so we get to a failed state. And like if we have for example, a replica set, it will create pods in a loop. And if the pods still land on bad nodes, like this like will cause a churn, and we would like to prevent that. So like there are two ways how to prevent it. One way is to have basically all information on the nodes. So basically the kube scheduler has like a gut view of the cluster and would know and every time what will happen. So one of the ways we can achieve that is to add more information to the node, so the kube scheduler knows before the scheduling, for example, as we see with DRA or node declared features, that it will help the scheduler, but it might not be feasible every time. So there is also a proposal for having like dynamic rescheduling. So the kubelet would basically tell the scheduler that this is not a feasible node and it should try elsewhere. Okay, so once we get to the running phase, after all the initialization and start of the pod completes, we also, like this, like a couple of states are bundled in this one, so we can have a ready or unready pod. There can be a resize. There is also one new working group coming up, which is called Checkpoint Restore, which also looks at new flows of like what containers can actually do. So they are looking at storing a state of a container and maybe run it later at like when we have more resources or when we have like some higher demand on the node, or migrate the pod to run it elsewhere. So there might be use cases where you could actually also have a pause state. And I think like the interesting part is like when we try to like disrupt the pod. So today there are multiple ways how to achieve the pod disruption, but the basic one is we just delete the pod. We have also API initiated eviction and some other means like taints. But like one of the big issues of the current disruption intents is that it's very late. So there is not much interaction we can do. So we have, for example, a pre-stop handler that can interact, or when we do a sick term, like a pod can try to like clean up after itself or something. But when we have like some more complicated scenarios, for example, we are trying to do the migration as, for example, with the checkpoint restore, or we have a VM running on the machine, or we have a pet application that doesn't handle the disruption well. We would like to have some like earlier intent of this disruption. And so this is basically not feasible like today. There are ways how to do it, but they are not very observable. So we, for example, have the API initiated eviction, and you can create like a validation webhook to actually react to this thing. But when we talk like from a higher level perspective of some node drainers, for example, like a cluster autoscaler, there is no like view of the cluster to actually know what is happening during a node drain, and we don't have a way how to predict how the node drain will actually happen. Okay, so one other way, like one thing that we are also missing in Kubernetes today is like having, for example, earlier autoscaling capabilities. So even when you have your application running, it's not possible to like preemptively scale out of the node. So if we would have a, like earlier intent and not try to solve like disruption with immediate disruption, we would we could get scaling and have less disruption in our workloads. Okay, so when we are getting like to the terminating like state or terminated state, we are also seeing problems there. So we have like a Graceful Node Shutdown feature that basically does not handle the disruption in like a way as other disruption models do. So we do not get a pod deletion, and we are just terminating the pods. But unfortunately, the node Graceful Shutdown doesn't have like a great observability of what is happening. So we are back to the observability. We cannot interact with the process, what is happening during the Graceful Node Shutdown. And so we are running into problems such as that we are unable to detect the pod termination, and the pod is still serving traffic, and we would like to react in our endpoint slices to basically remove the endpoint. Okay, so these are some links to some of these issues I just talked about. There is much more, and like we can see like the limitation of like the current observability of pod lifecycle, and how all the higher level layers or tools above cannot interact or cannot interact in a way we would like them to. So one of the things how we could solve this with like the eviction request API proposal, and this would basically allow us to tap into the intent or the disruption intent and disruption response. So we could do it by simply adding a field to a pod called eviction interceptors, and we would basically allow any controller or even third-party controller to interact with any pod interruption or disruption. And when we have a drain controller, that usually today just creates like imperative API evictions in a loop, and depending on the drain controller, there are some various clever ways of determining which pods should be terminated first and which last, and but it varies across every project. So we don't have like a common solution that we can depend on. And this could get solved by the eviction request, that we would still create these evictions, but they would be declared declaratively in an object. So we basically have a target and say what kind of pod we want to terminate or evict, but nothing happens at this stage. So then it should get picked up by our controller, which selects the interceptor. So we have a list of interceptors, and there can be multiple interceptors. And so we select the first one, and then we wait for that interceptor to actually do the difficult part of migrating or scaling the application out of the node, and to basically implement the more graceful eviction. One of the important points is the Harvey deadline seconds. So we do not want to end up in a state that someone promised that our application should be gone, but nobody will react. So we express this in our API by adding the deadline, and we expect our controller or the interceptor to actually add us, to actually tell us updates about how the eviction progresses. And so we can have multiple interceptors, and so we can have an interceptor that captures the logs, and then maybe we have another interceptor that does the migration. And so once all these interceptor completes, we expect that at least the last one will terminate the pod, and we will free our resources on the node, and we can continue with the node maintenance. If that doesn't happen, we can have a soft type eviction, which emulates the current API, imperative eviction API. And it would basically fall back to implement the same loop like the controllers are doing today, that we could evict pod imperatively and capture also the PDB information. So this is meant to be backwards compatible with PDBs and eviction API. So as we know, we have many termination mechanisms. So it's not just the API-initiated eviction. It's, for example, taints and tolerations and node eviction. So this would not work for every scenario, but we can try to improve the API in the future to add new types, or for example some deadlines. So for example, if you have a spot VM, you might not want to wait for an interceptor forever. And in that scenario, we would add new types that would all interceptors would react with them better. So let's see, and let's talk about the node lifecycle now, and I will give a word to Ryan.
Okay, can you hear me? There we go. A quick time check. I saw your hand. Is it 5 minutes? Oh, we're good. Okay, that was a we're good. Okay, thank you. So Node Lifecycle. I think everyone here is probably pretty familiar with like Node Lifecycle. We've probably all managed a Node Lifecycle in some way or another. And I put together like a list of some different ones that we've probably all experienced in one way or another. So like things like ready, we see this a lot. We provision nodes, we coordinate them, we drain them, we do maintenance on them, we upgrade, repair, shut down, reboot. We will validate them, we'll return them, so we'll bring them back into the cluster, we'll remove them. So all these things we're kind of all familiar with, we do them a lot. But there are several challenges today with actually managing the Node lifecycle. And so I'll kind of come up with a scenario here. Let's say if I was to start draining a node, like if we had a 1,000 node cluster and I was to go to my laptop here and start draining, right? The first thing I would do is I'd do a kubectl drain. Like we all do this. And if I were to tell you in the audience to say, okay, can you find which node that I'm draining, right? Is there a way you could do it? And so I told you I'm draining, and let's say it's node 3. So from the audience, any idea what would a node look like if a node was draining? I know you're all thinking it. You'd see the node is cordoned, right? You don't have a microphone. I could tell you. I wanted to shout that. Thank you. So the node is cordoned, right? You could find it. It's like that node is like something's happening to that node. It's cordoned. It's like I did a kubectl drain. I'm doing something to it. It's probably node 3. So it's going through a drain. Okay, now it's done draining. Right? I just told you that. But how do you know? How do you know it's done draining? What if I didn't tell you that? So it's kind of interesting. Like, what could you do? Well, you could go to the node. And you could look at the pods. Right? You could say like, oh, there's some pods there. Some daemon sets, maybe there aren't. So it might be drained. But me telling you, like, you could be like, all right, that's drained. So let's say we weren't in the same room together and I couldn't just tell you this. How would you know? How would you figure out if this node is actually drained? Well, there's probably several ways we could do this. I could label a node. I could say, hey, it's drained, or annotate it, or I could write a CRD and say, hey, this thing's drained. And we can communicate that way. So there's lots of ways we could perhaps come up with how we can interact over what's occurring on this node. So that's interesting. It's actually like what you see a lot in the community. Like there's so many projects that do this. They annotate nodes, they write conditions, they write CRDs, and they sort of describe what's happening to a node. There's countless of these things in the ecosystem. So that's interesting. And what's kind of hard about this is like which of these projects would I want to use? Like which is the one like we could use to like work together, like integrate as a solution? They all solve it a little bit differently. So I think sort of like the next challenge, we'll go to a different scenario. This is a real world one. So I work at NVIDIA, and one of the things that I encounter all the time is that we have these clusters. My team manages like hundreds of Kubernetes clusters. We have 50,000 GPUs that we manage. And these GPUs run into different problems where a lot of times, probably the most common one we run into is we're in the driver. We run into a driver problem, like driver will lock up and we will not be able to do anything with the GPU. So the only cure to that is that we have to reboot the node. And at a scale of 50,000 GPUs, we'll see this between 100 to 1,000 times a day. This will occur. I see some heads nodding. I know yeah, we see this a lot. And I've been to had several conversations about this, and it appears in different forms. You could have XIDs and various things that can occur. And you have to reboot the node. And so how do you do that? And so when we were kind of dealing with this as a problem, we looked at several solutions. Like we actually adopted some of them, like Node Problem Detector, we incorporated. But there were sort of several nuances to it that we found that were missing, where like we wanted to have this idea that we could drain nodes and do it at large scale and coordinate the drain, kind of like just how we did that exercise, how I explained like, how do you know like the node is drained, right? We basically wanted to do that exercise at scale and then reboot, right? We basically, with Node Problem Detector, we'd put a condition on the node and say, hey, like this GPU is broken, like start draining it and then reboot the thing. And so we ended up coming up with our own various solution for this, and it works well. And I think the challenge that, basically the challenge that I want to bring up was that, well, like how could I share that with people? Like a lot of people buy NVIDIA GPUs. I'd like to give this to people. I know that people experience this in different ways. Like I'd love to hand it to people, but it's not that simple. I think that if I came up with a solution, like my solution uses CRDs, but like, is my CRD solution the right one for you? So I think there's like a lot of nuance to it, and I think what the challenge is like, what's like a way, like with Drain, like how could we collaborate? Like there's not really necessarily a canonical API for me to say and point to and say, well, this is what draining is, or this is what drained is, and I just provide a driver that says, okay, well, this is what's going to enact the drain or the drained state, whatever you want to call it. Anyway, this is kind of like a theoretical way that we've been kind of talking about it, but that doesn't exist. And kind of what the challenge is like that would be a way we could collaborate, is that I could provide you like that idea of my perspective of a driver that would get you, to a drain state so that you could then reboot your node. So it's a challenge, and I think I'll give one more example. This is a different one. I think if you're using like a public cloud provider, I've heard of from people where like let's say you're renting GPUs in a public cloud provider, and you're doing like training, and you're doing a bunch of training, and you got a bunch of GPUs, and you need to upgrade Kubernetes. So you've got your nodes, you've got your GPUs, and a lot of times when the cloud providers, the solution for doing this is you'll see like a blue-green upgrade. And this is a great solution. You could provision new hardware and provision new GPUs and a new node with a new version of Kubernetes, and then we migrate the workload over. So a lot of times what I see is that people will say, well, I don't want to move my workload over. I actually want to keep my GPU because I spent a bunch of time optimizing it. I did my training on there. I configured it. I did all these things where like I would like to hold on to it. I would like to drain my node and upgrade it in place instead of migrating over. Like, how would you solve that in the public cloud setting? Well, I don't know. I mean, the problem actually comes kind of similar, where like I'd have to tell you that my node is drained. Like, how do I communicate that? I'm not really sure, but like that would be a way that you could do this. You could say, okay, cloud provider, my node's drained. I need you to upgrade me. Like, go ahead and do that. So that's a possibility. Something, I don't know, just an idea that we've been thinking about is that there's several challenges there, and that I think there's sort of opportunities to like evolve in the space, and I think really the challenge is like with the ecosystem is a lot of fragmentation, and we're trying to find ways that we can take all this collective knowledge and come up with different ways that we can have these projects work together, right? I can't write my project and it's not going to integrate with like the cluster autoscaler. I think even the cluster autoscaler has their own version of like how they do drains and stuff like this. Like there's all these things that exist. How can we make them work together? So that lack of interoperability, the fragmentation, it all increases complexity and we're duplicating effort, and it's all these various things that are challenges. And I think, so like one of our goals in the Node Lifecycle Working Group is we're looking at ways that we can try and reduce that, how we can have these projects work together. And so we had a few things we've looked at, efforts we've been following. These are 4, like Graceful Node Shutdown. So Filip mentioned that one as well. You can kind of think of it in the context of like Node Lifecycle. Like imagine a kubelet is going through Graceful Node Shutdown and it stopped, like whatever the kubelet stopped or the node rebooted or whatever accidentally. How does the kubelet know that it's supposed to still be draining? Like it's still supposed to be in Graceful Node Shutdown, so it kind of can lose track of what it's supposed to be doing. So that's like another area, like you can see how this feature or this concept of node lifecycle can affect these various different projects, like node readiness, node declared features, and then there's also from the DRA group, device taints and tolerations, other ways that we can describe what's happening to devices and nodes. Okay, so 2 KEPs or 2 issues that we've been focused on specifically with node lifecycle. The first one's declarative node maintenance. This one has been in discussion for a little bit, and there's a picture of the proposed API. We're definitely looking to build more, revive this kept more, and polish it more, and we're definitely looking for more feedback. But essentially the gist of it is that we want to provide an API that could describe how a node can go through maintenance. And then the second one is fairly new concept, a newly proposed KEP. This is called Specialized Lifecycle Management. And the idea is node lifecycle observability. So that idea, like I was saying earlier, I highlighted, like, how do you know if a node's drained? How do you know if it's like needs to be rebooted or something? Is there other changes we can make on the node to provide like some sort of canonical reference that we can describe these things and have a user, provide their input and through like a driver or whatever to tell us that this is what the node state is or something like that. So that's what we're thinking about, and really what we love for everyone that's interested, like we want to have more use cases, we want to build our use cases. If this is something that's interesting to you and you care about and you want a solution, this affects you, we're definitely looking for more use cases. We have a bunch, but we want to continue to build that. I think that would help us a lot getting these accepted and getting us on our way to fixing the problem. Okay, and then, so I've got 2 more slides. The second to last one here is about the working groups presentations. There's been several companies that have come and talked inside the working group about their lifecycle management and how they solve it internally. So this will just be as a reference to people that are interested if you want to watch them. There's some really good presentations. And then finally, like how you can contact us and getting involved in the Node Lifecycle Working Group. We meet weekly on Monday. We have a Slack group, mailing list, and there's a community page. So come and find us. We'll obviously be, in the hallway track. We'd love to hear from you, and we'd love for your help on any of our work. So thank you very much.
Thank you.
Do we have time for questions? Yeah. Perfect.
Hello. Yeah, thanks, guys. I just have one question, I guess. If you could summarize everything you just talked about in like one sentence, what's the goal of the working group? Like, what is when do you see it kind of dissolving? What would be the ideal end state to say, okay, we've now accomplished everything that we want here? Is it having a common abstraction that anyone could somehow implement that defines what node lifecycle looks like in any scenario, and maybe you have some pieces that you have to implement in a vendor-specific way, or what? Yeah, what is your kind of 2-second pitch of what the end goal of the working group is?
Can I? So I would say like observability and cooperation across different components.
Yeah, I think the ecosystem of Node Lifecycle there's so many products and solutions out there. We want to come up with a solution so that all these things can cooperate together, so that we can have Node Lifecycle be something that's sort of natively supported.
So it's kind of bring all these different things that are going off and doing things in their own way, but bring them all together so that they do something in a more cohesive manner, rather than solving pieces here and there without consideration for the other things that are going on.
Yes, and it will also like enable a whole bunch of new use cases that we are already tracking.
Okay, great, thanks.
Hey all, thanks for this. Node is a weird object. Like in our API, it's kind of unique in the way that it works. I think a lot of the things that we need to make this better are not unique to Node. They're maybe first in Node. They're the first one to really discover it, but I think that there are things that we're missing further down the stack in regular API object lifecycle management. And so I've said this on the KEPs and stuff, and we'll talk about it more in meetings. But I want to encourage everybody as we're looking at this to think about what parts of this properly should be pushed down into just generic API machinery, and what parts are really unique to the Node lifecycle. Because I think there's at least some that should be pushed down.
Yeah, I agree, and like we can see like there is a lot of abstraction in the ecosystem which builds above the node, like to achieve all their like problems with infrastructure management, etc. And like yeah, it would be great to find like the common ground to see like what will help everyone. Like if we bring something into the core, which yeah.
Fixing API machinery is not the fast track, but it may be the correct track.
Anyone else?
Any more questions?
Yeah, here. Okay, sorry.
Okay. I've often wished for an equivalent of kill -9 on my nodes, because sometimes like the finalizers have gone walkabout and you're trying to shut something down and it just won't. Do you address that sort of aspect?
Yes, this is like one of the things we want to achieve is that if you have a problem and you see something is not happening in the cluster which it should, like spot should terminate, node should also shut down and leave the cluster, and we basically want to give like opportunity for like various controllers to basically implement better behaviors, so you don't have to do the manual work. So like everything works just like, and you don't need any kill 9. It will work all fine.
Thank you.
We also had one question here. If we could.
Yeah.
Yeah.
So I'm looking at the 4213, and I was wondering, like, what is the cap is open for a while, but what is the blocking issue that you are like still gathering use cases, or like that is preventing us from?
I think well, I don't know if it's necessarily a blocking issue. I think the challenge with, so you're talking about the declarative node maintenance, right?
That's right.
Yeah. I think there's a lot in the cap. I think there's a lot of ideas. I think at least in my mind, like I think the challenge is how can we distill some of it down a little bit. I think like when Filip originally created it, it included like eviction, and then we've broken off eviction, or he broke off eviction. And I'm still like, I guess, where it's not sort of a blocker, but it's sort of like how can we distill some things down a little bit more. So it's like we were talking about observability. So I think like that's at least what I'm thinking about is like how can we, what are the pieces we could take off and try to make those implementable as well. Like I think that they can work in parallel. I think that there's nothing really blocking it at this point. I think it's just trying to figure out what else we could break from it.
Can add one last thing, like we try to also make sure that we are doing the correct thing. So that's why we have this working group, and that's why we would love to hear your use cases to actually see that we capture everything and that it will be useful for everyone, and so we can also move further. Okay, I think we are at time. Thank you very much again.
Oh, there's another question. Go ahead.
Okay.
Yes. They cut you off.
Hello? Oh, there we go. Yeah, I'm not sure exactly how to phrase this, but I think the node, the concept of a node, I think, like looking to the future, like 5 years from now, I think like what a node is going to evolve a bit. Like I know we're starting to see some of this coming through like DRA, and thinking about kind of virtual nodes or clusters of nodes. I see the idea of a node getting a little more fungible. Like from within just the SIG node perspective, there's also like what components make up a node. Like the kubelet is no longer like just the like one, like we used to kind of think of node as synonymous with the kubelet, but now there's this whole cluster of plugins and things running on the node, and that's kind of evolving too. So I'm not sure exactly where the question is here, but like, is this something that you're thinking about in the Node Lifecycle Working Group, and thinking about how some of the concepts that you talked about, like, will evolve as the concept of a node evolves?
Yeah, I think so. I think like like when I was talking about the node lifecycle, I mean, I feel like, at least to me, like it could be a composable part of the node, where like we almost think about it now in the abstract, and we do it already in various ways, and you know, maybe it's like something. I mean, I like the example of DRA because like the way it sort of decomposes it to include devices. I mean, perhaps there's other ways to, like you said, just decompose it to, you know, maybe there's something we could do with on the life cycle side. And,
Yeah.
So I think it's a great question. No, John wants to do it too. I agree that the idea of what is a node, little n node, what is a thing that runs workloads, is necessarily going to shift over time. We can see it in the past with things like virtual kubelet, which is a node but not really a node. And we see it in things like sandboxes, which are things that run workloads but aren't a node at all. And we can see it now in things like compute domain, which describes a thing that runs a workload but isn't many nodes. And so I don't know if it's literally repurposing the object we call node capital N, or if it's finding a new abstraction that describes these things that becomes the thing that runs workloads. But I do think that is a very open space right now that is necessarily going to be important.
Yeah, something similar. Like one of the things in DRA we're doing is everything you can do, like from a scheduling and resource accounting point of view with a like node allocatable, you can now do with a device. So we could actually, and then we're talking about moving native resource, an understanding of native resources into drivers and communicating with kubelet that way. So you could actually have a DRA driver that publishes multiple compute devices that can independently run pods, like maybe they're DPUs, or maybe you can run a pod on your NIC, right? Maybe you can run, like, and so it's decomposing like both a single kubelet to many little runners, as well as the other way that Tim was just saying, like groups of nodes that execute groups of pods, and it's really a fun space. But
yeah, then how do you life cycle something
Exactly.
that's no longer? Yeah, I understand. Yeah, it makes sense.
And how do you stay compatible with the massive ecosystem that already understands capital N node?
Yeah.
Yep.
All right.
We are getting
we're getting
into
the
time.
boot.
Thank you.
Thanks,
Yeah.
everybody.
Thanks a lot, everyone.